This video is part 6 of a series about building a simple database and two SQL statements, a select and an insert. Quick recap of earlier videos. The many-to-many relationship between an actor and the films they appear in is normalized using an actor-film linking table. The linking is achieved by taking the primary keys in the actor and film tables and making them foreign keys within the actor-film linking table. The actor and the film tables contain test data, and those tables are linked via the actor-film table. DB Browser was used to create and populate with data the tables required. This screenshot of DB Browser shows in the bottom pane the SQL is executed to actually build the table. So this menu is a good way to learn basic SQL syntax. Then a select query was built up which contained two inner joins so that an actor could be linked to the films in which the actor appeared. For this stage, I'm going to take an SQL query that has been built and tested within DB Browser, as seen in the previous video, and try to migrate it to Python. An extract from the real Python website clearly describes the overall purpose of a database management system and how this can be demonstrated using Python and SQLite. SQLite is built into Python, which makes the installation and configuration process a lot easier than installing and configuring a separate database management package and server. Note that SQLite is a teaching aid, not intended for a production environment, serving many thousands of users simultaneously. But for this demonstration, where the objective is to design, implement and understand basic SQL, the performance of SQLite is more than adequate. The Python software developed in this example could certainly be improved and migrated to run against a more scalable database management system. Therefore, SQLite and DB Browser can be thought of as prototyping tools during design and early development, as well as an educational tool. The section of the standard Python documentation covers SQLite3. There are several steps that have to be executed before it's possible to execute an SQL statement in Python against an SQL database. The first step is to import the SQLite3 modules into your Python program. Next, define the connect identifier, in this example con, to an external file containing the SQLite database that was built using DB Browser. Throughout the program, the database is identified via the identifier con. For this example, the file name of the database doesn't have a path because it resides in the same folder as the SQLite database where the Python program is executing. For an SQLite database in a different directory or drive, a more detailed path would be needed to locate the SQLite database. For this example, I'm keeping things simple. The program and the database are in the same folder, so no paths are needed. After defining the connection, a cursor, C, is defined, which is highlighted in yellow. Then the execute method is called against the cursor C. To summarize so far, define a connection to the database, then define a cursor for that connection. In this example, all the SQL statements are executed against the cursor name C. This example is copied from the clear and detailed Python documentation. The execute method is executed twice against the cursor C. The SQL commands are highlighted in grey. In the first statement, a create SQL command is executed to create a table called stocks. Following the create, an SQL insert command is executed to insert data into the stocks table that has just been created. Notice that the SQL is written within triple quotes. These SQL commands could, and I would recommend, have been created and tested within a tool like DB Browser before inserting them in a program written in a high-level language like Python. In this example, notice that there are 1, 2, 3, 4, 5 parameters in the create statement, and there are 1, 2, 3, 4, 5 values passed in the insert statement. So why test in DB Browser before inserting in Python? That way separates the SQL errors from any Python errors. After the create and insert SQL statements have been executed, there is a need to commit them to the database. So this is a commit to the connection. If no further SQL statements need to be executed against the database, then the connection needs to be closed. In summary, the SQL statements are executed against the cursor, but the changes are committed against the connection. The Python documentation states that issuing your SQL query in Python using string operations is insecure, although I would need to do more thorough investigation to understand what that insecurity actually is. Since the data to be inserted in a table in the database is probably already held in a variable, documentation recommends you use what I call the question mark technique. In the SQL statement to be executed, place question marks wherever SQL expects a value. Then create a tuple or list that contains the data you wish to use in your SQL statement and assign that tuple to some variable, in this case t. I emphasize the data string r hat to be used is contained within parentheses followed by a comma, making it a Python tuple. Within the statement that executes the select, the where clause does not contain the parameter value directly, but contains symbol equals question mark. Following the select string, there's a comma, and following the comma within the execute is the identifier or variable that contains the data that's going to substitute for the question mark. It's rather indirect, but this is the recommended way to code this. In the Python or documentation, single quotes, not triple quotes, have been used, something else that needs further investigation, but not now. Executing this select statement will retrieve one or more rows that meet the condition in the stock table. Find all rows where the symbol column has a value of RHAT. How is the data now made available to the Python program? This particular example uses the fetch1 method applied to the cursor C. The contents of the first row in the database that is found to match a symbol value of RHAT will be printed. There may be other rows with a symbol value of RHAT, but those rows would need to be fetched separately. A more sophisticated query where we want to identify and extract records that match a variety of data values, is to put the required data into tuples, see the parentheses, then collect those tuples within a Python list and assign that to an identifier, in this case purchases, highlighted in yellow. After the purchases list has been created, then the execute many method is run against the cursor C. This SQL statement inserts into 3 rows of the stocks table data taken from each of the 3 tuples in the list purchases. The principles I've just been through from the Python documentation will now be applied to the actor film database. I take the very simple SQL statement, select star from actor, and build it into a small Python program. After SQLite has been imported into Python, define the connection between the database file name and the identifier con. Next, the cursor is defined on the con database. The execute method is then applied to the cursor, where the parameter is the SQL statement select star from actor, contained within triple quotes. Next, the fetch all with no parameter is applied to the database cursor, and the results stored in the identifier rows. Rows is a Python list. One way to extract the data from the rows is to use a for loop where the elements in the rows list are inserted into the identifier row one by one. Then each row is printed out. A row will contain multiple values, one for each column, in the initial definition of the actor table. I also inserted the type row in a print statement to make it clear what type of element was being output from the SQL database. Finally, there is a commit for that SQL statement. The result of executing that Python program with the embedded SQL is shown on this screen. The SQL select generates a Python list, and then each element in that list is a tuple that contains the data values extracted from the table actor. Data values in each row are the actor ID, followed by the actor name, followed by nationality, followed by date of birth. An indicator that each row is a tuple is that the data is enclosed within curved parentheses and the data values are separated by commas. Overall, we have seen that an SQL statement, if it returns one or multiple rows, will be made available to the Python program as a list or array containing tuples.